Hello, welcome again. We are solving GATE 2025 Mechanical Engineering paper. Question number 39 is wire drying operation is performed on a perfectly plastic metal without any strain hardening. Assuming no friction and no redundant work, the maximum possible percentage reduction in area in a single pass is closest to option A 51.2, option B 63.2, option C 75.0 and option D 93.2. So we know that the flow stress is sigma is K is equal to epsilon delta N, where sigma is flow stress, K is strength coefficient, and this epsilon is true strain, and N is constant. And from this formula of flow stress, we can calculate average flow stress like that. So average flow stress is sigma average, and 2 strain is epsilon. So that is the work done then if average flow stress happens at all the time in the material. And but the total or we can say that is the strain energy stored, okay, strain energy stored per unit volume. But the if variable stress act on the element, then the strain energy stored in the element is sigma into d epsilon integration limit 0 to epsilon. So this is the strain energy stored per unit volume if sigma or variable stress is acting. This is the strain energy stored per unit volume when a constant stress sigma average is acting on it. Now we can put the expression of sigma. Sigma is K epsilon raised power n and integrate it. Then we get this expression, and this then and we can take this epsilon or sigma average comes out as K epsilon n plus 1. Okay. So now we have one another expression for draw stress, that is sigma average into epsilon. So this is equation number 3. This is sigma average. Now when draw stress and flow stress are equal, and putting the value of sigma average from this expression, we get epsilon. We put sigma average this and epsilon this, and this is flow stress. Then K will cancel out, and then epsilon and will also cancel out. So here it will be only epsilon, and here there will be nothing, or only one is there. So epsilon will be equal to 1 plus L, and epsilon is nothing but 2 strain, and 2 strain in terms of area can be represented as ln ai by af. Okay. So now the maximum reduction will occur when this exponent is 0. Okay, so when exponent is 0, then flow stress will be equal to strength coefficient, and ln ai by af will be equal to 1, or ai by af is equal to 2.718. Okay, so that is ai by af is 2.718, and the formula for reduction is initial area minus final area by initial area, or we can say 1 minus af by ai. Ai by af is 2.718, so af by ai will be your inverse of this, that is 0.3679. So reduction will be here. This is corresponding to maximum reduction because n is 0. So the reduction will be equal to 0.63208 or 63.0208%, option B.